I welcome all to the session 30 on current electricity of BSc third semester as prescribed by Karnataka University, Dharwad. Today, in this session, I am dealing with Biot-Savart's law. The outcomes of this session are as follows. Understand the basics of Biot-Savart law and identify the relation between magnetic field and current. Apply Biot-Savart's law to find the magnetic field due to an arbitrary current in a conductor. Find the direction of magnetic field produced around the current carrying conductor. Before going to Biot-Savart's law, let us know about magnetic effect of electric current. We all are aware that when the current is passed through any conductor, it produces magnetic field around it. This effect was for the first time proposed by Ørsted and is called as magnetic effect of electric current. This effect forms the basics of Biot-Savart's law. Biot-Savart's law is also known as Laplace's law. This law was formulated by the two French physicists Jean Biot and Félix Savart. This law allows us to find the strength of the magnetic field due to an element of current carrying conductor. As shown in the figure, let us consider a long conductor carrying current I. Let n be the point at a distance r from the current element QP. At this point n, we are going to find the strength of the magnetic field produced due to the current element QP. Let theta be the angle between the current element IDL and the line joining the current element to the point N. Then, according to Biot-Savart's law, the magnetic field produced at the point N is found to be directly proportional to the current flowing through the element. That is, del B is proportional to I. It was found that the magnetic field del B is directly proportional to length of the current element, that is, del B is proportional to dl. It was found that the magnetic field is directly proportional to sine of the angle theta between the current element and the line joining the current element to the point N. That is, del B is proportional to sine theta. Del B was found to be inversely proportional to square of the distance of the element from the point N, that is, del B is found to be inversely proportional to r square. Combining all these four relations, Biot-Savart has given an equation which says del B is proportional to IDL sine theta divided by r square. The same equation can also be written as mu naught upon 4 pi IDL sine theta divided by r square. This equation is called as Biot-Savart's law. Here, mu naught upon 4 pi is a constant and its value is 10 raised to minus 7 Weber per ampere per meter, where mu naught is the permeability of the free space. SI unit of magnetic field is Tesla. The vector form of the same equation can also be written as del B is equivalent to mu naught upon 4 pi I dl cross r divided by r cube. Statement of Biot-Savart's law. Actually, Biot-Savart's law is an equation describing the magnetic field generated by the constant electric current. The magnetic field due to the current carrying conductor is directly proportional to length of the current element, strength of the current element, sine of the angle between the current element and the line joining the point, and inversely proportional to square of the distance between the point and the current element. That is, del B is equivalent to mu naught upon 4 pi I dl cross r divided by r cube. Magnetic field del B is a vector quantity and it also has direction. Direction of the magnetic field is found to be perpendicular to both the current element I dl and the position vector r of the point N and can be found by the right hand clasp rule. Right hand clasp rule states that if the current carrying conductor is held in the right hand such that the thumb points the direction of the current and the other 4 fingers curl around the conductor as shown in the figure, then the curled fingers shows the direction of the magnetic field produced. Biot-Savart's law is helpful in finding out the magnetic responses even at the atomic and molecular level. This law is applicable to very small current carrying conductors. This law is analogous to Coulomb's law in electric field. The reference books for this session are Electricity and Magnetism by Satya Prakash and S. Chance, Electricity and Magnetism by R. Murugesan. Thank you.